Solving multi-step equations, TEKS 5A. Hey guys, today we will be solving equations that are multi-step. Previously, we've discussed solving equations that take only one step or two steps, but anything three or more we call multi-step. It's important that when you're solving that you do things in a specific order. On the front of your foldable, you should have this little picture here with the phone, and it will help you to remember which order to go in. You should always distribute first, next combine any like terms, then move your variable to only one side of the equal sign, add or subtract, and then last multiply or divide. You see the first letter of each thing, D, C, M, A, M. To remember this, you could remember the saying, don't call me after midnight, where the first letter of each word corresponds with the first letter of the order that you need to use when you are solving multi-step equations. So inside your foldable, the front of your foldable, we're going to look at the bottom side now. One of the special solutions is if you do all the work and at the end, the statement is equal. So for example, like that first one, x equals x. Well, that is true. X does equal x. Or the second one there, if 4 equals 4. As long as they're equal on both sides, the answer will be all real numbers. So let's go back inside our foldable, back to the front of our foldable, and that's on the bottom right. So we talked about what happens when the statement is equal, but what about if the statement is false? What if you do all the work and at the end you end up with 7 equals 3? Well, that is not a true statement. 7 does not equal 3. And same with that second example. Say you were to work it out and you end up with 2 equals negative 2. And that's kind of a trick question because they're both 2, but one side is negative and one side is not. So that means they're totally different numbers. So if you ever get a statement that is false like this, your official answer should be no solution. So let's look at an example of that. Let's look at a few examples. Let's look at the top left. So what we're doing when we're solving equations is we are trying to isolate the variable. In other words, we want the letter C to be all by itself on one side of the equal sign. So if I follow the steps that I had in the front, I'm going to draw a line down the equal sign, by the way. Okay, so if I follow those steps, the first step I would need to do is to distribute. You only need to distribute if you see parentheses, which in this equation we do not have any. The next step would be to combine like terms. You have to look at one side of the equal sign at once. So on the left side of the green line, one has a C and one term does not. So they're not like terms. On the right side of the equal sign, one has a C and one does not. So those are not like terms. So again, the first two steps don't really apply to this equation. The third step, move the variable to one side, does apply. Right now, I have C's on both sides of the equal sign. I have a 5C and a 7C. We want to rearrange it to where there's C's only on one side. Doesn't really matter which side. Personally, I always move the smaller one. So between 5 and 7, 5 is smaller, so that is the one that I'm going to move. And we move it by using inverse operations. Since it was originally plus 5C, we are going to subtract, which will cancel it out on the left side, leaving us just 8 equals. On the other side, 7 minus 5 will give us 2C, and I have to bring down that minus 2. Okay, the fourth step is to add or subtract. Right now, I have minus 2 on the right side. So again, we're going to use inverse operations. So this time I'm going to use plus, and I'm going to do that to both sides. Cancels out on the right side. So I'm left with 8 plus 2 equals 10 equals 2C. And the last step is to multiply or divide. Right now the C has a 2 in front of it. It's implied that they are being multiplied. So you are going to do the opposite and divide. 10 divided by 2 is 5 equals C. So now the C is by itself. So that is your final answer, 5 equals C, Or if it makes you feel more comfortable, you can do c equals 5. As long as the c is all alone, you are done solving this equation. Let's look at the example to the right of that. Okay, so I'm going to put a little reminder here so I remember what order to go in. So D, C, M, A, M. I am going to go in that order. I'm going to draw a line down where my equal sign is, just to keep track of both sides. My first step is D for distribute. So in this case, I do have parentheses. There is something I can distribute. I'm going to get this 1/3 and I'm going to multiply it in. When you multiply by 1/3, it is the same thing as dividing by 3. So 1/3 times 18 will give me 6. And I have to do the same thing to the other term inside the parentheses. 1/3 times positive 12 gives me positive 4x. Okay, on the other side, I also need to distribute. This time it's 6, so 6 times 2 gives me 12x. 6 times negative 7, see that minus sign there? Gives me negative 42. The next step, so we're done with distribution. Next step is to combine like terms. But again, you're looking at one side at a time. Neither side has any like terms, so we can skip that step. The next step, M for move the variable. So between 4x and 12x, 4 is the smaller number, so that is the one that I'm going to move. It'll cancel out on the left side, leaving us just a 6. But on the right side, 12 minus 4 gives us 8, so 8x minus 42. Done with that step. The next step, A for add and subtract. So this minus 42, we're going to do the opposite and we are going to add. And what we do to one side, we have to do to the other. 6 plus 42 gives us 48 equals 8x. Done with that step. And last step, the last M is for multiplying and dividing. So this 8 and x, they're being multiplied together. So what we're going to do is we're going to divide. And 48 divided by 8 gives us 6. 6 equals x. And that is our final answer since x is all by itself. So these are pretty basic multi-step equations where we end up getting an answer. What I mean by that is we end up with a number. With the first example we did, c equals 5. On the second example, x equals 6. But there's going to be times where you come to an equation that'll give you a funny answer, or we call them special solutions. So if you and let's work out the problem on the bottom left. Now I think you can tell that the answer is going to be all real numbers, but I want to show you how we get there. So following the steps from before, we are going to distribute, combine like terms, move the variable, add and subtract, multiply and divide. So let's start with distribution. 6 times negative x gives me negative 6x. 6 times 2 gives me positive 12 equals. So now let's do the same thing on the other side. 3 times 4 is 12. 3 times negative 2, because of that minus sign, gives us negative 6x. So distribution done. Next step for combine like terms, you have to look at one side of the equal sign at a time. Let me put my line so it's easier to see. On the left side, the first term has an x and the second term doesn't. So they are not like terms. See that? One has an x, one doesn't. On the right side, this one is just a plain number. In other words, it's a constant. But here, this one has an x. So again, they're not like terms, so I can't combine them. So when it comes to that step, you can just skip it because there's nothing to do. then M for move the variable. So I have negative 6x on one side and negative 6x on the other side. They're both the same number. So in this case, let's just choose whichever side we want to start with. So the opposite of negative would be plus, and it would cancel. And then same thing here. I would plus 6x. But guess what? It also cancels, and I'm left with 12 equals 12. So see how that is a true statement. 12 does equal 12. Whenever you end up like this, where it's the same number on both sides of the equal sign, we say that the answer is all real numbers. This is a special solution. It won't come up very often, but I wanted to make sure that you guys knew what it meant if that ever happened. Okay, there's one more kind of special solution. So back to the inside of the foldable. And let's look at the bottom right. So I'm going to draw a line where my equal sign is. And then a little reminder of our steps that we need to follow. Okay, so let's do D for distribute. On the left side, there's no parentheses, so there's nothing that I need to distribute. But on the right side, I have negative 4 times 1 gives me negative 4. Negative 4 times negative 6 gives me positive 24a. So we're done with this step. Again, there's no like terms in this one, so we can skip. M for move the variable to one side. So this 24a on the left, I'm going to subtract that and cancel it out. But what I do to one side, I have to do to the other side. And it also cancels out. So I'm left with negative 22 equals negative 4. So these numbers are not the same. So this is a false statement. If this ever happens, your official answer should be that there is no solution. Again, this is not something that will happen very often. 99.9% of the time, you are going to get an answer to your question like the top two examples that we did. But every once in a while, one of these special solutions will pop up, and I wanted you to know the difference. So today's assignment looks like this. It's only 4 questions. What I want you to do is to practice working on multi-step equations, and then this is going to go in your notebook as well. This will not be turned in. So 4 different equations. And I did what I did on the note. So there's going to be one that is no solution, and there's going to be one that's all real numbers. Then the other 2 will have regular number answers. Okay, guys. See you later.